Okay, this is business stats homework number 8 um, in my labs or my stat lab. The previous video was a little wonky. I wasn't pleased with it. So I decided that I would do a cleaner version of homework 8. So let me get it open for us and do a preview. And I also want to show you how to do this in Excel. So hopefully everything loads up for us properly. Here's our first question. It says the following is a set of data for the population with n equals 10. We want to compute the population mean and the population standard deviation. So during class last week, I discovered how to do this in Excel. So we're going to click on this little box here and open it in an Excel document. Okay, so it opened down at the bottom. Well, give me one moment for that Excel sheet to open for us. And here it is. All right, so in order to find the mean, which another name for the mean is average, I just click outside into a separate box. And under formulas, go to more functions, go to statistical, and then we're going to click on average. Okay, so to get the mean, you're going to select the first cell, and then I'm hitting on my keyboard Shift, and I'm selecting the last cell to highlight all of the data, and then press OK. And that is my mean. Now, instead of trying to write down the number, I'm doing a right click on the answer, and I'm doing copy. I'm gonna minimize that, and then I'm gonna do a Control V to type my answer in. Make sure that we're using the correct notation. It says an integer or a decimal, so that appears to be fine, and click OK. So part A is done. On part B, it says to find the population standard deviation. So it says population standard deviation. I'm going back to my Excel sheet. I'm clicking on, and we could give this a name if we want to, and call it mean. Okay, on the next one, I want the population standard deviation. My population standard deviation. So here again, I'm gonna go to formulas, more function, statistical, and scroll down until you get to standard deviation, and it has P. So when you hover over it, it tells you what it's calculating. It says calculates the standard deviation based on the entire population. Okay, so that's the function that we want. For my data, I'm selecting the first cell, pressing Shift, and selecting the last cell. So that highlights the entire data set, and then press OK. And that is my population standard deviation. I'm gonna right click to copy, and Control V to paste. Now notice this will say surround 2 decimal places. Okay, so 2 decimal places, so it will be 2.65. So we're just gonna back that up. And this should be the correct answer. Okay. On problem 2, it says consider a population of 1,024 mutual funds that primarily invest in large companies. You have determined that the mean 1 year total percentage return is achieved by all the funds is 5.80. So right now, we know that my mean is 5.80. And that sigma, the standard deviation, is 1. Okay, so we know that the mean is 5.80. And my standard deviation, sigma, is 1.0. Complete parts A through C. Okay, so it says, according to the empirical rule, what percentage of these funds is expected to be within positive and negative 3 standard deviations? So we know on our empirical rule, and let me switch this to my camera. Here we are. So we know on the empirical rule, 1 standard deviation, the percentage was 68%. We know 2 standard deviations is 95%. And we know that 3 standard deviations is 99.7%. So going back to my question, what percentage, according to the empirical rule, what percentage of these funds will be between positive and negative 3 standard deviations of the mean? The answer that goes in there is simply 99.7. For the empirical rule, those percentages are standard. Part B says, according to Chevyshev's, what percentage of these funds are expected to be between positive or negative 6 standard deviations? All right, to get that percentage, let me go back to my camera. All right, for Chevyshev's, we had a formula that said 1 minus 1 over k squared would give us the percent between k standard deviations, equal percent of k standard deviations. Okay, so they're asking us for 6. So in our case, my k is 6. Yours may be a different number. On one handout is 7. On another one, it may be 4. So all we're going to do is replace the k with the number of standard deviations that they're asking us for. Okay, so that is 1 minus 1 over 6 squared. Into your calculator, 1 minus 1 over 6 squared. I get 97.222. So that's about 97 point, and they want us to round 2 decimal places, 22%. So in my box here, we said 97.22. Round 2 decimal places as needed. check the answer. Okay. On part C, it says according to Chevyshev's rule, at least 96% of these funds are expected to have a 1-year total returns between what two amounts? Okay, 96 is between some minimum and some maximum value. Okay, 96% is between some minimum or some maximum value. We have to figure out how many standard deviations does 96% represent. Okay, 96% represents what or how many standard deviations. To figure this part out, and again, yours may be different, to figure out, we have to find K. Well, we already know that 1 minus 1 over K squared is going to give me that percent. Now we're given the percent, which is 0.96, is equal to 1 minus 1 over K squared. We have to figure out what K is. Okay, so solving for K, we're subtracting 1 on both sides. And that's giving me a negative 0.04 is equal to a negative 1 over K squared. A little cross multiplication action in division. That gives me a negative 0.04 K squared is equal to negative 1. And again, I'm cross simplifying. I'm multiplying K squared times that guy. And now I need to divide by negative 0.04 to get K by itself. We got K squared is equal to, this becomes positive 1 over 0.04. And then lastly, we need to take the square root to find K. When I take the square root of 1 over 0.04, we get a 5 for my K. And let me verify that I've done that correctly. Okay. So once we have my K, now I can find my minimum and maximum value. Your minimum is going to be your mean minus 5. Your K is 5 standard deviation. Your max is going to be your mean plus your K that we just found, which is 5 standard deviations. Plug and chug. What was my mean from the reading? The mean from the reading, if I'm not mistaken, is 5.8. The mean from the reading is 5.8. And my standard deviation is 1. Okay, so I have 5.8 minus 5 standard deviation of 1. Your max. Okay, a little bit of computation. 5.8 minus 5 gives me a minimum of 0.8. 5.8 plus 5 gives me a max of 10.8. I'm off the page. Okay, so let's go. I'm on the wrong one. Here we go. Okay, so answering our question. I'm just verifying my computation. And we want to round 2 decimal places, so here we are. So it is between 0.80 and my max was 10.80. It says 2 decimal places, so that's why I included the 0 at the end. And so that was number 2. Right, number 3. Number 3 asks us, this is the one that has multiple parts. It has like 14 steps to it. So we'll try to work through these. All right, so first thing, it says the data to the right contains the per capita energy consumption in kilowatt hours for each of the 20 provinces of a nation. We need to calculate or compute the mean, variance, and standard deviation for the population. So just as before, we're going to take this box and copy it to an Excel sheet. And we need the mean, the variance, and the standard deviation. So we're going to open it up in Excel. We're going to try it again. Don't want it to save that one. Okay, let's try one more time. Here, open in Excel. Oh, it popped on at the bottom. I missed it. All right, so here we are. That's my data. So the first thing they ask us for is the mean. So remember, in order to find the mean, you're going to go to formulas, more functions, statistical, and average. We're going to highlight the first cell and do shift in the last cell. Press OK, and it should return us the correct results. I'm going to do a copy and Control V and check. For the population variance, back to my Excel sheet, I'm going to go to formulas, more functions, and we're looking for population variance. So I'm going to scroll all the way down to variance, vars, bar, population, calculates the variance between, okay, that's what we want. Select the first cell, shift, last cell, click OK. I'm going to copy. I'm going to do a Control V, and it says round to the nearest integer. So I'm just going to take off my decimal. And check answer. That's my variance. And then it says population standard deviation. And if we need to, we could say this is my mean. This is my variance. And we're getting ready to do standard deviation. Standard deviation, go back to formula, more functions, standard deviation at the bottom for population, standard deviation P, select the first cell, shift, select the last cell, press OK. There's my answer. And do a copy and Control V. This one says round to the nearest integer. So back out the decimal. The decimal is a 5, so that 0 is going to go to a 1. All right, so here's the next piece. It says, what percentage is between one standard deviation of the mean? What percentage is between one standard deviation of the mean? All right, so in order to do this, I need to figure out my minimum and maximum value and count the number of data entries that fall between that minimum and maximum. Count the number of data entries that fall between that min and max. Okay, so what we need to do is find my minimum and maximum. I think I need to go back here. Okay, so my minimum, remember from on the last problem, your minimum is equal to x bar minus k times sigma standard deviation. My max is x bar plus k times the standard deviation. Okay, so we need those two data entries or values. My x bar, if you go back to your Excel sheet, my x bar was my x bar was 12,379 minus k represents the number of standard deviations. So right now, my standard deviations is 1 times sigma, which is my standard deviation, which is 3690 or 91. Remember, we had to round. Okay, so you could enter that into your calculator. Your max is going to be same numbers, but plus 1 times 3691. Minimize that one. All right, so on our calculator, all we need to do is the 12,379 minus 3691. $86.89. And then here we're going to add I forgot 91. We're off one there. So at this point, we need to go to our data set and count the number of entries that fall between 89, and 16,070. All right, so that's one way of computing this information. Another way, if we look at a curve, okay, our mean is in the middle. So my mean is, or was, what? 12,379. We could go out one standard deviation either side. Okay, our standard deviation that we got previously was 3691. So we could do 1, 2, 3, 7, 9, and just simply add my standard deviation, 3691. That's going to give me 16070, subtract 8688. We could go out again. This is one standard deviation to the left. This is one standard deviation to the right. We could go out two standard deviations by simply adding another standard deviation of 3691. That gives me 19761. On the other side, 8688 minus 3691. That gives us 4997. And then one more, either side. I'm going to take 197.61 plus another standard deviation. That gives me 23,452. Subtract. And on this side, I get 1306. All right, so we're looking for one standard deviation. How many data entries lie between 86, 88, and 16,070? So if you go back to your data set, is it in order? No, it's not in order. All right, so we want to sort the data. See if I can remember how to do this. Sort my data. All right, now it's in order. So we want to count how many data entries are between 86, 88, 86, 88, okay, so notice you see that my minimum, again, we're looking for all of the data entries that are between 8,688 and 16,070. 16,070. Okay, so the first one that will be included will be this 8879. And since it's already sorted, we're going to go all the way down to this line 17, which is 15,899. So if we count the number of data entries that are between these two values, including those values, you will see that we have 14 data entries that are in between. Okay, so you're going to take that 14 and divide it by the total number of data entries, which is 20. And that gives us 70%. Okay, so let's go back to our deal. It says the percentage that falls within one standard deviation, we got 70%. Okay, on the next one, the percentage that falls within two standard deviations. If you go back to my list, okay, within 2 standard deviations, wrong list, let's go here. 2 standard deviations fall between, so we know that this is 70%. 2 standard deviations is between 49.97 and 19,761. This is 2 standard deviations. Okay, let's go back to my data set. And let's go from 49.97, 49.97, 49.97, that's 49.74. So that's not going to be my starting. And we need to go all the way to 19,761. Okay, so notice how many data entries are there. All of them except for this one. So that means I have 19 out of 20. That percentage is 95%. So I just took the 19 divided by 20. And they gave us 95%. Okay. So 2 standard deviations is 95%. And then lastly, 3 standard deviations. So if we go back to my paper, 3 standard deviations is between 1,306 all the way to 23,452. Okay, for 3 standard deviations, if we go back to my list, the smallest was 13, so that now that picks up this last one all the way to the end. So that includes my entire data set. So that one is at 100%. All of my data values are included. So 100 there. So that piece is done. It says 9 more parts, guys. It says compare and contrast your findings in part B versus what you would expect based on the empirical rule. So remember the empirical rule, let me go back, says that 1 standard deviation, 68% of the data will fall within 1 standard deviation, 95% will fall within 2, and 99.7 will fall within 3. Well, if we compare that with my answers that I got, notice on my answers, we got 70%, which is close to 68%, 95, which was right on the button, and then 100 for 99.7. Okay? So what can we conclude about my data? We could say that the values are close to those predicted by the empirical rule. Okay, now in part D, it asks us to repeat A through C, but this time we're going to remove the value of 12,593. Okay, so I'm going to go back to my spreadsheet. I'm going to remove the data entry, 12,593. 12,593. There's that data set. And I'm going to do a right click and let's see. I wonder if it's going to change. Let's just do a delete. Watch these numbers. Let's see if that changes. Yes, it did. Okay, so let's try these new values. When I took out that one value, it changed my mean for me. So let's test these and see if these are the correct numbers. Let's do a copy. The mean, and it says to round 2 decimal places. Control V. My 2 decimal places is going to be 0.74. Let's see if it did it for us. Yay. The variance spreadsheet. Let's pick up my variance. And it says to round to the nearest integer. So we're going to take off the decimal. And lastly, our standard deviation. And take off your decimal. All right. And then we're going to go through and set up another distribution for our min and max. Count the number of data entries in between. In other words, you're going to repeat this process that we did up top. Okay, your mean is now 12,367.74. You're going to add 1 standard deviation, 2 standard deviations, 3 standard deviations, and count the number that's between the number of data entries that are between those values. All right, so I think you can handle that from this point. And I wonder if it's going to let me go on. Surely it will. You sure want to leave this question? Yes. And then this is the same thing. It's asking you to calculate the mean and the standard deviation and interpret the results. So this one only has 2 parts. Again, let me show you how to do this in Excel, just real quick. Open in Excel. I'm outside. For my mean, I'm going to go to formulas, more, statistical, and average. Select the first, select the last. Okay. This one says round 3 decimal places. So hopefully that rounded correctly for us. Standard deviation, you're already in that spreadsheet. Formulas, more functions. What was it? Standard deviation. And sigma, remember sigma is population. First shift. Okay. This one asks us to round 3 decimal places. So 3 decimal places, 5, 6, 7. Okay, on this one it says interpret the parameters calculated in A. Assume that the market capitalization, the standard deviation, is as large as a proportion if the proportion of the mean if it's greater than 25% of the mean. Okay, so what does that mean? You're going to take your standard deviation and divide it by your mean. My standard deviation was 142,567 over 216. Okay, so that's more than 25%. It's small. The standard deviation is large as a portion of the mean. This indicates that the values are relatively spread out. There we go. All right. So again, I just had to come back and do a cleaner version of homework 8 because my the smart board wasn't quite working as well as I would have liked. So hopefully this helps get through the homework. If you have any additional questions, feel free to send me an email, text. You have both of my methods of communication. If nothing else, I will talk to you later.